In this video, we will explain on modern concrete placement technique that consists of shotcrete, concrete placement for underwater using ceramic concrete and ceramic pipe, and also pumping of concrete. We do also conclusion for our presentation. Shotcrete is a method of placing concrete by using pneumatic system with a high velocity flow to achieve high strength and low permeability concrete product. The concrete is conveyed by a hose with attached nozzle and projected using pneumatic system at high velocity to the receiving surface. Like any other concrete product, shotcrete also can be combined with normal reinforced steel bar, steel mesh, or fiber materials. In theory, the spraying of concrete into the surface at high velocity is a perfect method of concrete placement where the placement and compaction are done at the same time. Individual aggregate coated with cement paste are driven into place to form a void free mass of fully compacted concrete. Shotcrete can be in a foam or either dry mix or wet mix version. For dry mix, shotcrete is a method of placing the dry concrete ingredient into a hopper and conveying it through a hose to the nozzle. The water is added at the nozzle during the spraying process. The concrete will be sprayed to the targeted area and will completely mix at the receiving surface. The process of spraying dry mix shotcrete may cause some dust from the dry mix ingredient through the entire spraying process. Meanwhile, wet mix shotcrete is involve the placement of ready mixed concrete into the nozzle. Compressed air is introduced at the nozzle to drive the concrete to the receiving surface. The process of receiving the wet mixed shotcrete will have less dust and rebound compared to the dry mixed shotcrete. Next, we move to concrete placement for underwater using ceramic concrete and ceramic pipe. Placing concrete under the water or sea floor is a very challenging task for these engineers. The construction of in-water structure such as one foundation, anchoring system for offshore platform in oil and gas industry, and other marine and sea structure require special concrete placement method so that the concrete can be delivered according to the desired quality standard. Casting concrete under the sea is often required advanced quality control. Therefore, competent person is required to perform the placement of underwater concrete in the first place. There are two types of concrete pump that are consist of based on support mounting and based on operation. For based on support mounting, it consists of line pumps and boom pumps. Meanwhile, for based on operation, they are consist of direct acting concrete pumps and squeeze type concrete pumps. Now, we are explaining in detail each type of concrete pump. For line pumps type of based on support mounting, it has a versatile portable unit typically used to pump not only structural concrete but also grout, wet screeds, mortar, shotcrete, form concrete, and sludge. Pump manufacturers offer a variety of different line pumps to meet a wide variety of needs. Line pumps typically employ valve type pumps, while the smaller model are often called grout pumps. Many can be used for structural concrete and shotcreting where low volume output is suitable. They are also used for repairing underwater concrete, filling fabric foam, placing concrete in heavily reinforced section, and building bond beams for masonry walls. Some hydraulic-driven models are pump structural concrete at output exceeding 150 cubic yards per hour. costs for valve pump are relatively low and there are few parts. Because of its simple design, the pump is easy to clean and maintain. The units are small and the hoses are easily to handle. For line boom pumps based on support mounting, boom trucks are self-contained unit consisting of a truck and frame and the pump itself. Boom trucks are used for concrete pours for everything from slabs and medium high-rise building to large volume commercial and industrial project. They range from single axle truck mounted pump used for their high maneuverability, suitability for confined areas and cost performance value to huge 6-angle rig used for their powerful pump and long reach on high-rise and other large-scale projects. Next, direct acting concrete pump. The operation of the direct acting pump is simple. The concrete is fed into the pump by gravity and partly by suction created due to the reciprocating motion of the horizontally acting piston, while the semi-rotary valve open and close alternately. Ideally, the diameter of the suction pipe should be at least 3 times the maximum size of the aggregate on the concrete to be pumped. Next, we move to squeeze-type concrete pumps. Squeeze-type pumps are smaller portable peristaltic type pumps. The concrete from the collecting hopper is fed by rotating blades into a flexible pipe connecting to the pumping chamber. Squeeze pumps can transport concrete up to a maximum distance of 90 meters horizontally or 30 meters vertically. Due to the cumbersome mechanics of squeeze pump, direct acting pump find greater field application compared to squeeze pumps. There are several requirements for pump concrete, such as: first, concrete mixture should neither be too harsh nor too sticky, also neither too dry nor too wet. Second, a slump between 80 and 150 mm is recommended. Third, if the water content in the mixture is low, the coarse particle will exert pressure on the pipe walls. Friction is minimized at the correct water content. The presence of a lubricating film of mortar at the walls of the pipe also greatly reduces the friction. Fourth, high cement content in concrete is generally beneficial for pumping. Fifth, water is the only pumpable component in the concrete and transmits the pressure on to the other components. Next, we move to factors affecting the productivity of pump concrete. Many factors influence concrete placing profitability. The placement method is a major determinant of the placing pace, but the pour shape and position are technical factors which also influence the productivity. Congestion at the site and other conditions for entry will render continuous supply difficult or impossible, even if the concrete supplier is able to maintain regular delivery. The practical issue of supplier scheduling is complicated by the fact that nearly half of the sites change the order quantities during the pour, often dramatically. Next, we move to slip form construction technique. This construction technique is an alternative for conventional formwork system which help in continuous vertical and horizontal construction. The slip form helps to conduct continuous pouring of the concrete to the moving formwork. The process stops only when the required length of casting is completed. There are few components of slip form. The slip form system has a number of functionalities. It generally consists of legs with yokes. Yoke legs are used to lift and hold the whole structure weight so that it functions as one entity. Yoke legs are also used for connecting to column, scaffolding, and work platform to serve the purpose of support. To the yoke legs, walkaway brackets are connected. This walkaway bracket will enable proper placement of the concrete. The entire slip form assembly is lifted using strand rod and lifting jack. Such primary components are placed at equal interval to achieve uniform and good weight distribution. Lifting method is assisted in some construction by the use of hydraulic pump component. There are 4 numbers application using slip form construction technique. First, construction of regular core high-rise structures. This slip form design method used in the construction of high-rise building will be carried out by vertically extruding the portion of reinforced concrete. This method easily builds standard shape core structures and building. Second, slip form technique for chimney construction. This slip form method that is used to build large chimney cooling tower and piers is called tapered slip form. This technique is used to create vertical structures of different wall thicknesses or shape or diameter. Third, construction of steel tank. This slip form construction technique help in the cost-effective construction of the large volume system in industries and factories. And fourth, construction of water tower. The slip form technique help with better quality to build the water tank walls uniformly. This system quickly builds tanks of thousands of liters. There are few advantages of slip form construction technique. First, it is non-stop method of construction. Second, it can increase rate of construction. Third, it can increase the productivity. Fourth, it provides more working space. And 5, creates safe work environment for the workers. There are few disadvantages of slip form construction technique such as high cost for initial setup, requires specialized workers and expertise, needs sophisticated equipment, and dimensional accuracy can go low in certain conditions. As a conclusion, this study provides information on the industry outputs and capacity and the productivity achieved in concrete posts on big buildings have been provided. The profile covers concrete supply and site placing aspects. The data distinguish the productivities being achieved between different placing methods. So, that's all for our presentation. Thank you for watching. Bye!